Uh, Hello, I am Akshat Kochak, and today we are discussing the first internal test of analysis and design of algorithms. So, here the first question arises that the complete the table after simplification of the corresponding recurrence relation. So, here in the table we have given algorithm relation, and we have to find the time complexity, space complexity, and the power complexity for linear search, binary search, and so on for the given relations. Now, second question is write the recursive algorithm for the polynomial representation. And the third question is write the iterative version of Tower of Hanoi problem. Coming again to the first question, we have time complexity, space complexity, and power complexity. First of all, we will learn what are these three terms. Time complexity may depend on the various factors such as the specific input to the algorithm, the efficiency of the implementation, and the use of any auxiliary data source, data structure, or algorithm. In practice, the actual running time of the algorithm may also be affected by various external factors such as hardware limitations, operating system overhead, and the size of the input data. Now we have given some uh, algorithms which we have to put in this table. So the value of linear search is order of n, so we will put order of n here, and in the place of n in this, and we will like that only we will solve the another questions also, the another algorithms which are given to us. uh, Now, similarly, for the space complexity depend on other factors such as implementation detail and the specific input to the algorithm. In some cases, the space complexity may also be affected by the use of auxiliary data structure of or temporary variables. So here again we have given the algorithms and their values which we have to put in the which we have to put in these relations, and then we can easily find the value of space complexity. Now for power complexity, the power complexity of an algorithm is a measure of how the algorithm's running time grows as the input size increases. It is typically expressed in terms of the exponent in the running times big O notation. Note that the power of complexities of the algorithm are not the same as their time or space complexities. The time and space complexities may have different constant or lower order term that affect the actual running time or memory uses of the algorithm. Here also we have given the algorithm and their values which we have to put for finding the power complexity of the relation given in the table. Here we have given some examples and some methods that how we have to solve and how we have to put the given information in the relations, and how we have to solve the questions. Now we will come to the second question. We have to write the recursive algorithm for the polynomial representation. So the algorithm defines a class of polynomial with a constructor that takes a list of coefficients. The evaluate method evaluate the polynomial for a given value of x. The base case of the recursion is when the polynomial has degree 0, that is, it is a constant polynomial. In this case, the method is simply returns the signal coefficient. In recursive case, the method creates a polynomial p of degree n minus 1 by removing the highest degree coefficient from the list of coefficients. It then recursively evaluates p for the given value of x and multiplies the result by x. Finally, it adds the highest degree coefficient to obtain the value of polynomial for the given value of x. Now here we have given that the algorithm works by breaking down the problem of evaluating a polynomial degree n into the problem of evaluating a polynomial of degree n minus 1. So like this we will solve and we can find the recursive algorithm for the polynomial representation. For the third question, the iterative version of Tower of Hanoi problem, we have to write the iterative version. So the this implementation uses a stack to keep track of the recursive calls that would be made in a recursive version. The stack start with the initial call to move and disk from the from rod to the to rod using the aux rod as an intermediary. We will use these terms for calling them in the disk. In each iteration of the loop, the top call is popped from the stack and executed. If there is only one disk to move, it is moved and loop continues. Otherwise, two recursive calls are pushed on to the stack. One to move the n minus one disk from rod to aux rod using two rod and as intermediary, and other to move n minus one disk from aux rod to two rod. Finally, the call to move remaining disk from the from rod to rod is also pushed into the stack. This process continues until the stack is empty, at which point all the necessary moves have been made to solve the Tower of Hanoi problem. Here given the brief description that how we have to use Tower of Hanoi problem for writing the iterative version. Thank you.